Hello all, welcome to another session with me, Varun at OdinSchool.
I hope you all know why our language is important and how it is useful, and how our language makes a difference and what is our language special for. All right. Now, going forward, let me introduce you to Odin School. Odin School is a technology upskilling platform, and we continuously strive to ensure that you acquire new skill, because of which you could stay skilled and stay ahead. And guys, my name is Varun. I have an experience of 7 years, and over these 7 years, I've been working as a developer and as a trainer. And in this tenure, I've been able to work on different languages like HTML, CSS, JavaScript, which happened to be some very famous front-end languages. And later, I moved on to SAP and then moved on to Python and machine learning and so on. It's all thanks to my work. Now, going forward with the agenda of this session would be to continue where we dropped off in the last session. So I hope you all remember that in the last session we saw what is graphs, what is stats, what is data visualization, and we dropped it off partly. All right, and in this session we would be moving, or we would be covering exactly from where we stopped in the last session, though we would be touching on some points which might be a bit in common between the last session and this one. But yeah, the overall agenda would be to understand data visualization types of plots, and also we would be working on the hands-on exactly where we left yesterday. So guys, I hope you all know that when we talk about data visualization with R, the main goal of data visualization is to ensure that you are able to interpret your numerical data in uh, a visual format, or probably in a graphical format. All right, that is the main aim of any data visualization tool or any data visualization activity. All right, now here when we talk about representation on a graphical front, or probably on a visualization front, we would be using a lot of libraries that we have built, or that we have provided by R. And some very famous libraries, as we all know, are the first one to begin with is ggplot2. ggplot2 is a very famous and a very widely used library, and ggplot2, uh, I hope you all know that ggplot2 also helps in coming up with all sorts of basic plots. Like it could be any kind of bar, or a histogram, or a pie chart, or probably any complex variant wherein you would want to ensure that there is a theme to it, and probably there is grid layer to it, and you have 2 to 3 vectors which are going along in with it. So if you would want to work on all such features, then you can use ggplot2. But if you would want to simply work on basic plots and stats, then you don't need any library. R is capable enough to ensure that basic charts or plots, right? Basic charts or plots come up. That is something that R can take care of even without installing a library. But just to give you all an idea about the names of different libraries we have in R, let me just write it down here. You might want to make a note of these names that I'm coming up with. So the first is ggplot2. We all know this, that's already written. The second one is HiCharter. HiCharter is another library. Then we have Leaflet. All right, we have Plotly. We have RGL. We have R Color Brewer. So these are the different libraries that we have available when we talk about R as a language. All right. Now each of these libraries is used for a different purpose. For example, here when you talk about HiCharter, right? It is basically as you can see the name itself, it is to make charting easy, or you can say that it's to make dynamic charting easy. right? So dynamic charting becomes very easy when you work on high charter. Also it has some great themes which are inbuilt, which are used by the Economist and Financial Times as well. Then the next one we have is leaflet is also pretty important. Leaflet is used when you generally want to work mostly on interactive maps, right? So whenever you have the process of working with interactive maps, that is exactly when you would want, or when you might want to learn, or sorry, when you might want to use a leaflet library. All right. Going forward, we have R Color Brewer. R Color Brewer also is a great library when you might want to represent different vectors or different elements in different color. All right. And then the next one we have is Plotly. Plotly is again an online platform for data visualization. All right. And then you have Sunburst R. Okay, I've not written it here, but we have something called as Sunburst R. Okay, these are also great for visualizing. You can say a timeline or probably a sequence of events. So if you would want to come up with something like that, then Sunburst R is probably the most preferred library. Then you have something called as RGL. All right, and when we talk about RGL, RGL is mostly for 3D or good or advanced 2D graphs. All right, here you can come up with a lot of variants of animation, or 3D scenes can also be worked on this. Okay, then you have so I think we've covered a brief understanding about almost all the libraries that we wrote here about. All right, so guys, notwithstanding this, it is also very essential for us to know that there are some very important libraries, notwithstanding only libraries for data visualization. There are also some very other important libraries. For example, we have uh, DPLYR. DPLYR is a very important library. We all should know where and when DPLYR is used. Likewise, we have Plotly. So there are many packages that we have available, and we should have an idea about these. For example, you have PURRR. PURRR is for data. In fact, both of these are for data manipulation. All right. Then we have something called as TidyXL. All right, we have HMISC. All these libraries are very important. All right, then we have another library like TidyR. This is also for data wrangling on your data manipulation. So guys, these are some very important libraries. Now, why do we need to have an understanding about these libraries? Is because a lot of libraries which are based out of data visualization are directly dependent on this or on these libraries. All right. Now, when I say these libraries, it is DPLYR and PURRR, and you have TIDYR. All right. So these are the different kinds of libraries that we have available. Okay. So that is the most important part that we would want to understand when we are working on R as a language. So we all know the most important tool or the most famous tool that we have is RStudio. Now RStudio can be downloaded as an offline app, or probably it can be worked upon using Anaconda Navigator as well. Even in Anaconda, you have an R Studio, which is an online version of the same, right? And the tool which we are working on is an offline model. All right, guys. So that's exactly what we would be doing. So let us go forward and now understand a hands-on of the data visualization part and exactly where we dropped off yesterday. All right. So, and also there's another very important library which is called as R Color Picker. Okay, it's COLOR, and I suppose PICKER. Guys, I'm not very sure about the spelling. I would request you to go ahead and probably make a small note of the different libraries I've mentioned and check them. All right. Now, when we use different libraries for different purposes, it's not necessary that all of these are in sequence to each other, or probably all of these are in necessity with each other. All right, so that is the most important part. So now what we'll do is let us go to the next part of it. Okay, so yeah, so here is the most important part of this session. All right, and in this part, we would be focusing on the different types of plots, the different types of charts or graphs, and we would be looking at each of them in detail. In the last session, we had an understanding about some very basic plots, but then, guys, there are a lot of other plots that we did not talk about. So, in this session, let me give you a small understanding of what are the different types of plots we have available in the field of data science or why data science in the topic of data visualization. We keep it very simple and ground rather than going very high-fi. All right, so here you can see we have, I'm just naming a few. We have something called as function plots. I'll just write plot as a P. Okay, and notwithstanding a function plot, we have binary decision diagrams. So we have binary plots. All right, we have circuit diagrams. Circuit diagrams are also a part of very important part of development. Circuits are mostly for people who come from engineering backgrounds. You have timeline charts. Guys, these are some variant of charts that we don't generally work upon, but are still very important when you're working from probably a an organization's perspective. Then you have something called as a tree diagram. Tree diagram is if you would want to understand the hierarchy of your organization, including the photos of the directors, or probably the photo of your managers followed by supervisors. Now in that case you would be having to use a tree diagram. All right, then next you have sunburst charts. All right, we just saw what is a sunburst. We just understood what it is. The next one is a line graph. All right, the next one is a stack plot, or stacked area. These are generally called as area plots, okay, or stacked area charts. We have bar graphs, we have histograms. These are very common names. You have something called as a trellis bar. Trellis bars are very useful when you would want to create a 3D bar graph. A 3D bar graph, if you would want to use, is when you can say you can use a trellis or probably a lattice format. All right, now trellis or lattice. All right, now going forward, we have stacked area charts, we have pie charts, we have variants of pie charts, we have Venn diagram. Now Venn diagram and pie charts, I am pretty sure all these are something that we must have done right in our schooling. All right, then we have scatter plots, we have just in trellis we have different variants, like we have trellis bar, we have trellis line, we have Pareto charts. So guys, as we keep talking about the different variants of charts, you would see that almost all these charts are probably meshed up, or they're probably grouped up into 5 to 6 variants. For example, bar graphs or histograms and pie variants. Now within these, I would say there are probably around 15 variants of pie bar charts, or again you would be having subsections of these. So in total there are around good 40 to 50 odd variants of plots that you should probably just know about, but it's really essential for you to have a good understanding of at least, I wouldn't say 5, but yes, at least 10 plots. And the most important of these, I mean, the most important literally are a bar chart, a pie chart, then we have a histogram, we have a scatter plot, we have a donut, right? Then we have area chart, all right. These are the six which I'm able to remember right now. But yeah, as we keep going further, we would take a look at other plots or other charts also, which are very important. All right. So yeah, now we'll talk about each of these charts in detail. All right. And the first one that I would want to talk about, which we would be covering in this session, would be a uh, bar chart, all right, and then we would be moving on to a box plot. But even before we talk about a bar chart, I think we all have a basic understanding of what is a bar chart. In bar chart, we have a y-axis and we have an x-axis. All right, but when you talk about a box plot, guys, I mean box plot also would be having the same thing, or the same detailing. But when you talk about a box plot has a lot of inference that can be picked up from it. So what we'll do is, before we talk about any other chart in this session, let us talk about a bar chart first, and then probably we could talk about the other sessions, or we could talk about the other variants of graphs later. All right, so let me just clear up the screen before we go further. All right, I'm sorry, I think that brought us to the last slide. All right, so now we can go about understanding this. So here, when we talk about, a box plot, guys, a box plot is generally something like this, which has something called as the median. All right, and this here happens to be the minimum, and this here happens to be the maximum, with each of the segment, probably divided into 25% each. I mean, now this is how ideally it should be. And now, when I say ideally, I mean the most normally distributed box plot should have a distribution or should have a segmental cut like this. But if you're talking about, probably a skewed box plot, okay, a skew, SKEW, you see that it might be something like this, wherein it is inclined towards one side, and you see that the median is shifted and it's not at the center. All right, but and here there is, a violation of 25. I think this is 10. This is somewhere at around 30, and this is 50, or something like that. But yeah, this is skew. All right, and we know that when it is inclined towards the left, then it is called as a right skew, and when it is inclined towards the right, it is called as a left skew. All right. So skew becomes a very important metric when we're talking about box plot, or when we are talking about, understanding the distribution of box plot. All right. So that is the takeaway here. Now going forward, we'll continue with the different uses that we have associated with a box plot. All right. Now when you talk about a box plot, let me just make a note of things here. You might be interested in taking them down. So first things first, box plot is useful when they show the average of a data set. All right, we all know what is the average. Average is the mean of a data set. But here, okay, when we talk about the image, okay, the image generally shows the median. All right, and half the scores are greater than or equal to this value, or and most of the times half are less. Okay, then the second one, as we've already discussed, box plots, they show the skewness. All right, that is, if your box is lying towards the center, then you can assume, or you can claim that it is normally distributed. All right, now there is a way of how we calculate the skew, and we can check how much of the matrix, or how much of your data is skewed. You can do that using IQR, which is your inter quartile range. All right, So that's the part of it. And now the next thing, or the next use of a box plot is they also show the dispersion. Okay, now dispersion is the place where your IQR comes into picture. Okay, dispersion is also called as the spread, or it is also called as the variability. All right, so all these are the most important, character features of a box plot. Notwithstanding these, they also show your potential outliers, guys. We do not have a box plot here, but if you look onto a box plot, whenever you see that you have something like this, which is a bit away from your topmost, it could mean that these are your outliers. Okay. Now, box plot can, show your potential outliers, because of which it becomes easy to identify them. All right. Then the next one is, so yeah, these are some very important uses where it can be used. And also, talking about the different ways we compare a box plot. Okay, guys, now we are talking about all of these because they happen to be your questions that you might be popped up in your interview directly. All right, so here, right, the next one that we would want to understand is about the comparison matrix. Okay, or how do we compare box plots? All right. So here, when we talk about box plots, we would be using the median method, step one. All right, wherein we can compare using the median. Then we have step two, wherein you can compare using the IQR, the interquartile range, or probably the whisker part. All right. The third one is you can use the outlier method, all right, which is not very preferred. And then yes, skew also can be used as a method for comparison. All right. And let me just explain skew to you here with a graph. Probably I think that should make things easier for us. Now, if your image is okay, I think it's a bit okay. Now, if this is one, and then here I would be coming up with another wherein you see that this is how it is. Then this happens to be the left skew, wherein you would be having a higher whisker here and a lower whisker here. And this is left skew because it's inclined to the right. Now, because this is inclined to the left, this obviously has to be a right skew. And here you would notice that your box would be more towards right, and the whisker would be more free towards your right hand side. All right, so that is how we identify skew of a given figure. All right. And now going forward, let us look at the next part of it. The next graph that we would be talking about is a scatter plot. We all know why and when and where we use scatter plot. Let me just remove this here. All right, so now talking about scatter plot. So okay, here we have a scatter plot. This is your y, this is your x, and scatter plots are generally used to check a couple of things, very important things. First one is your error distribution. All right, there is something called as homoscedasticity. If you people remember, skedasticity, well, the spelling is pretty complex. Okay, so we have something called as homoscedasticity, which talks about how is your error distributed. So that becomes a very important way, or very important. Now, whenever you want to check about homoscedasticity, you can use a scatter plot. All right, now notwithstanding this, the next part where you could use scatter plot is to check the linearity of your data set. Okay, whenever you use something based on linear regression, or whenever there is a project that you might work on linear regression, then the most obvious chart that you would want to use would be a scatter plot. All right. Then the next one we have is a pie chart. When talking about a pie chart here, as you can see, is considered as a whole region, wherein the whole represents 100%, or wherein one unit represents 100 percent. But whatever, at the end it is considered to be 100% of data. And here we are mostly concerned about the contribution that it has towards each of the sector, or contribution which each sector makes. All right, so that here is the most important thing in a pie chart. Now, here you can understand that this is 40. Now, I have four sectors, wherein one is for advertising, one is for marketing, all right, one I have here, which is for sales, and probably this is some for something else. And I see that because of advertising, I have the highest cut in my profit chart, and advertising has contributed the highest. So this way, if you would want to understand the contribution, is when you can use a pie chart. Then the next one in order we have is a line chart. And when we talk about line chart is generally used when you might want to check the pattern A, or probably when you might want to check the trend, or it is also now because of these because of insights into trend, we use this also in TSA, that is time series analysis, right? So when you use time series analysis, then that is when you would want to work, or that is when you would want to understand if your data is actually following a trend, or if there is a seasonality or not. Though when we're though we don't use only line graph to understand all these inferences, we use different variants, but yes, this is one of the most important inference. Then the next one you have in order is an area chart. Area chart, as you can see, it talks about the area covered, A, and B, area chart also gives you an idea about the protruding, or an idea about the overlying or overlapping regions. So area chart can give you an a visual a deeper visual understanding, is what I would say. A deeper visual understanding about how much of a portion your trend, or probably your pattern or whatever is occupying. All right, then in order, the next one that we have is a spider, or probably a radar chart. We all know this needs no explanation. We all have been watching a lot of movies of late. All right, this talks about the kind of area that's covered within a given sector, or within a given unit. All right, or within a given region. All right. Then the next one we have is a comparison chart. We have stacked bar chart. This is also used to check the individual contributions on one single front. And this is a comparison chart. All right. So now that we have been able to understand different variants of plots for good, right? Let us move on to the hands-on part, exactly where we dropped off yesterday, so that we have a deeper understanding about the next part of it. Okay, so done deleting the screen. I think it's all good. You can now move on to the most awaited part, that is the R Studio. All right, so here you can see in R Studio, guys, I've already come up with a small piece of code here. And the small piece of code, as you are able to see, I am using a simple plot. Okay, and I'm considering my data to be numbers from 1 to 25. Okay, now here I'm using different properties like, and this is the output by the way. Just to keep you informed, here you can see that I have 25 different symbols, and all these symbols are coming up at random because in this piece of code, I have nowhere mentioned that I would, want it to now when I say it, I mean I want my graph to have these kind of symbols. It's not specified anywhere. All right, now these are the kind of graphs which might be of some entertainment that when you start to work on art, but trust me, it's not for long. It's just to start working so that you gain some interest, and then that motion you can take it forward into understanding different types. Now guys, whenever we work on any kinds of plot or chart, there is one very important website that I would want each of you to be introduced to, and the website name, or the website that I would be showing to you now is authentic website of R only. All right, so let me take you to that website now, and here we go. So as you can see, this is our documentation.org. All right, now this is the most authentic website that you can have when you would want to work on anything, or when you would want to learn about anything with regards to R, or with regards to some functionalities which we have in R. All right, so here you can see this is the same piece of code that I have copied, guys. And why I have copied this here and I've pasted that here for you to see is just for you to understand that things can be copied from here, and when you change values, you can see how it behaves on your R Studio. All right, now this works as an online forum. You can make changes here as well. For example, now if I delete this and if I click on run, you would see that my title is now changed. All right, we can make changes to this, that is not a problem, but then the most important thing is for you to understand how to work on such concepts. So here you can see you have a detailed description of each of the property that's being used here. So cex equal to 3, which means it's a character expansion. It controls the size of points. So every size that you have here is in this dimension because it is 3. Now let us change this to 5 and see. Now you see the size of each and every figure, or each and every block here has increased. All right. Then the next one we have in order is LWD. That is something which controls the line width. All right. Let us increase this to 5 as well to note the difference. All right, and now you would see that the width of the line has actually improved. Now when I say the width of the line, you can understand it to be the border. All right, then the next one is PCH. PCH gives you 25 symbols to choose from, as well as alphabetic characters. So let us just you know okay, let us just expand it on this forum. All right. So here, okay, it says 25 to choose from. Let us just zoom this. So here you can see I have different shapes, and I don't think there's any shape which is repeated. Okay, I don't think there's any dimensional shape which is repeated. This is a circle, this is a circle, this is a circle too, but this is a complete block of circle. This is a small circle with different color. This is a bigger circle which is green. This is a circle which is hollow. So guys, all these make a difference to the system. They might not make a difference to us. For us, this is a square and so is this, but for system, it is not. This is a square with a cross symbol. This is a square with a into symbol. So that's how it differs. So guys, here you see that there are freestyle shapes that have come up, and that's the reason why I have named the title also to be freestyle. All right, now let's go back, and then you have the color, because of which we have the color points. All right, Now, when PCH is 21 to 25, the points also get a background color which is set using BG. All right, so here you can see, because it is more than 21 to 25, and because we have used only 20, we are using BG because they would also get a background color. All right. So now if you would want to, so now he's saying that points for more on how to change the appearance of points in scatterplot. Now, if you want to change this into scatterplot, he's asking us to use points here. So let us just try it out. I'm not sure if it would get executed in this specific area or not. Okay, we don't have it here, but let us click on this hyperlink and check what is it that he's trying to tell us. Okay, so he's telling us that we could use points, and BG is a feature which can be used in points too. All right, and we have an example here with the code. So let us just check it out. All right, so here you can see you have good amount. Okay, so this is a scatter plot. All right, this is a sinusoidal wave, as you are able to see. Okay, great, you have that written on your y-axis, right? So here when you talk about your plot, this is a perfect example of a sinusoidal wave. All right, going forward, this is a scatter plot with multiple colors. This is a scatter plot with all red, and this is just a box with the plot frame, right, guys? So this is how we work on plots, or this is how we have an understanding about each of them. And these websites which I've been showing to you over the past few sessions happen to be the most authentic websites. And should you have any queries, it's a humble advice asking you people to work on authentic websites and gain information which is very genuine. Because what happens is, when you work on other websites, or when you work on sponsored websites, you might notice that they have inconsistencies because we are not sure when they have been updated latest. But when you talk about these websites, they are first updated in parallel with the launch of a library, or in parallel with modification or change in any libraries. All right. So guys, it's very important for us, or for you, and rather than saying important, I think it's very imperative. It becomes very imperative for all of us to have a sound understanding about some common basics, and knowing about different kinds of websites we have. All right, let us check what this is. This is another variant. Okay, so this is a lined variant. And how do we know that? Here you see LTY, he's using dashed. Okay, so it means that we are coming up with a dashed variant, and this line is in chocolate color, chocolate brown, as you can see. Cool. So now let's move on to the R platform, and let's continue from where we dropped off. All right, so here you can see this is the first thing that we wanted to understand. Now let us head on to where we dropped. So here, okay, here I have some inbuilt functions for you guys. Just something, of chart, of plots. So here, there's, okay, I think there's a change in path. I think we can copy this path that is available for us. So let me just copy this path here. We'll copy this path into inbuilt functions. We'll paste it here. Yes, I'll pass it into data set. Let's try this. Okay, cool. We have it. So now what we'll do is, let us understand some insights about data set. Now, this is something that we should have covered in the first session, but I thought it would be better when we look at this in parallel with data visualization, because that would make more sense. All right. So here, the first one that we have is str. All right, str gives you a structure of your data set. All right. And when we talk about str, here it is. You see, it has 21 columns and 7,000 rows. All right. So here it is. Let us just understand one of this, or let's just understand one of these. All right. So this is your number of rows. This is your number of columns. Okay, so from here you would be having a description about each of your column. So wherever you find a dollar, that is beginning of a description of a column. So I know that I have some columns, and here gender column is a factor which has male, female. Okay, then I have my senior citizen, which is an integer. Okay, then I have my partner, which is a factor again. So it has no's and yes. Dependence is a factor. Tenure is an integer. You see that there are continuous variables here. Phone service is a factor. But here, when you see, guys, there's one important thing that you might want to understand. And that is when you talk about senior citizen, which is an integer, right? Here, this integer has to be converted into a factor now. Okay, now when I say now, I don't exactly mean now. I mean to say that whenever you are working on any kind of integer column which is not actually an integer by sense, all right, in that case you might want to convert your integer into a factor. All right, going forward. So here we have description about the different kinds of columns, and that can be understood using your factor. Sorry, using your structure. Then the next one we have is your head. Head, as we know, would give you your top five records, top six records. Then you have your, if in case you might want to overwrite the number of inbuilt the number of default vectors that it produces in head, then you might want to give a comma followed by how many values you want to check. So here I have 2. Now if I replace or exchange this with 4, then you will see that you have 4. All right, the next is tail. Tail would obviously give me the last 6 values. You have end row. It will give me the number of rows, and call would give me the number of calls, and also you can the number of columns. And when you use functions like mean, min, max, they would give you exactly what they mean. Okay, so here there's no column named RT spend, so I think we can try it out for tenure, because that is a column which we have, I suppose. So you see that the mean tenure of my customers is somewhere around 32 months. So I can say that every customer who is taking my connection, or who is taking my subscription, is with me for an average tenure of 32 months. Now it depends on me about how I improve this, and or rather what are the strategies that I would want to improve this. The next one is the next one that we have is the minimum value followed by the maximum value, which is 72 months. All right, then I have my range. We all know what's a sample. Now when I do this, I think it's a very wrong way, but still it will give you some random tenures from your data set. All right, and these random are sample. Now when I do sample, it will give me random values, 5 random values from my data set. All right, now let us identify a column which is binary. Okay, I think we can just delete this. Okay, I think we can check it out for gender. And when you do a table of gender, okay, data set of gender, and you hit an enter, it will give you, the number of options you have within it. Like I have 3,400 females and I have 3,500 males. You can see that they're almost at par, they're just different by 100 numbers, and it's not a problem. So here, if someone asks you if they are uniformly distributed, you can say yes, they're almost uniformly distributed. All right, now having a difference of 100 numbers in a count of 3,500 is pretty okay. It's not huge. All right, so we'll go further into the most important topic, that is, graphs. And guys, yesterday when we were working on this topic, we have seen how to work on simple plots, followed by density plots, followed by histograms, followed by ggplot. We've understood what is ggplot, and even in ggplot, we have worked on histogram, we worked on bar graph, and today we'll be working on point graph. And or I suppose we have covered point graph as well, and today we will be working on box plot. Right, guys? Box plot is what we discussed about, and let me just, okay, it says customer churn not found. Well, I'm not sure if I've executed this data line here. All right, well, there's no customer churn record which is available in your global environment at all. So now I would be moving on into box plot. All right, so here I go, box plot. Cool. I thought, we might have an error, but yeah, that's lucky me. We don't have any errors. And here, as you can see, let us now zoom this and we'll have an understanding. Now, even before I blurt out about, what box plot is, I would ask you people to put the video on pause and also remind you people that if you have any queries, like literally if you have any queries, please use the comment section below. The comment section below is for you people to shoot queries you have, and we would get back to them at the earliest. Anyways, now talking about the box plot here, you can see that these regions are called as the whiskers. All right, whisker, or however you find it comfortable. This is your whisker. This happens to be your median. All right, this is your max and this is your minimum. All right, and these grids help us understand how your data is arranged, or how your box plot is divided, or things like these. All right, so this is simple variant of box plot, and I think we have some more variants. And here all that I'm doing is, in order to come up with this kind, we are using something called as fill, and this is something that we checked yesterday as well. Right, whenever you talk about fill, or whenever you add this property fill, you would see that your graph can come up with information for multiple vectors. And how is that? Here you can see I have monthly charges on my Y, I have internet service on my X, and this data is talking about genders, monthly charge, and internet service with due respect. All right, or respectively is also what you can say, either which ways. So yeah, so guys, that is what is happening here. So here I can say that there are, more number of females, or more number of people I think male and female in fiber optic are same. Okay, here I can say that there are more number of females just by a bit. Okay, just by a bit, there are more number of females who have DSL connection and are paying a monthly charge of, on an average of, somewhere at around 55. And I'm talking about fiber optic. I can say here, both the male and female are paying an average of around 90, and almost both of them have equal amounts of fiber optic service connection that they've enrolled for. So things like these can be understood when you work on box plot. And as I said, box plot inference is pretty high. And guys, what you see here is what is identified as an outlier. These points, right? They are, or they represent an outlier. All right. So outliers are when your data, or when your points are a bit way too beyond the normal reach. All right. So now going forward. All right, so here we would be now coming up with something very interesting, and I think this should be giving you fuel to practice plots for another couple of days. So here, when you see, there's something called as a facet grid. It says object G1. Okay, I think I did not execute this. Okay, so here this is what is known as a facet grid. Now, when we talk about a facet grid, you can see there are three types. We have DSL, fiber optic, and no, and people with no internet service at all. All right, now why is this, or why are these fields coming up? Is because I'm using tenure in my X and I'm using internet service in my fill, and this is a split of internet service types, right guys? So done that, and then I am using a histogram to populate them. Now when I would want another variant, oops, okay, so here let us now check this out. All right, so here goes my plot. You can see we have points here, or we have a scatter plot here, and these scatter plots which we have, or which we see, are linearly arranged. Now that is an inference. All right, that is an inference which I have understood. Okay, and you can see that it could be monthly, or it could be yearly, or it could be 2 yearly. The jump is almost the same, or probably the spike or the inclination is almost the same. All right, and then we're not done with it yet. We are now checking another variant of box plot. Okay, and here we can see that we have just increased the complexity by a bit more. I wouldn't even say complexity. All right, you can just see that I'm using different features, that is DSL and payment method on my X. And when I use payment method on my x-axis, you can notice that you have four payment methods, which is the reason why we are having an overlap here. All right, and as you increase, or the more you stretch it, the more you would be able to read them clearly. But that should not be something which should stop us from going further or stop us from understanding. So yeah, I hope you understood what is a facet grid and in which case we use them. All right, guys, in the upcoming session we would also be working on something called as a theme layer. And as you can see, this is the code of theme layer, and we would need another 30 to 40 minutes to talk about the theme layer, because it's a culmination of basic plots, plus it's a culmination of your GG plot, or your these kind of plots, plus new concepts like how do we add a theme, and how do we add different elements to ensure that your plot or your graphs are looking really nice and interactive and probably sophisticated. All right, so I hope you have understood how and why we use different kinds of plots, and how do we also come up with them when we work on our studio. All right, so the agenda of the session, I hope, is now satisfied and understood, wherein we have understood what is data visualization, we have seen what are the different types of plots available, and we did a hands-on too. And guys, now if you have really liked the video, and if you felt that this video might have helped you in increasing your knowledge base or increasing your fundamentals, then please do not forget to hit the like button. Also, do hit the subscribe button, and do not forget to hit the bell icon, because when you do this, you'll be having access to a plethora of videos and a great library to watch from. All right, stay subscribed, stay tuned. This is me, Varun, your trainer, your mentor, signing off, wishing you all the best.